alpha, beta and gamma decay. Whenever there was a radioactivity, three types of radiations were observed. One, neutral, means what? No charge, gamma radiation. One positive charge, alpha. One negative charge, beta. So the first part is alpha decay. What is an alpha particle? Yes, helium nucleus, two protons, two neutrons. In atom, there are two electrons moving around. If you remove these two electrons, what you get is helium nucleus. So this is alpha particle. What is charge on the same? Charge on this is plus 2e. What is alpha decay? Yes, the statement is phenomena or process of emission of alpha particle from nucleus. Emission of alpha particle from radioactive nucleus. So there is a big nuclei. Within this nuclei, you have an alpha particle, two protons, two neutrons. This alpha particle is emitted from the nucleus. If it moves to the right, then after emission, this part will move to left. That means you can mark it like this. If it moves to the right, alpha particle moves to the right with velocity v alpha, then this particle will move to the left with v, what, y or x? Y. Daughter nuclei is y. Time with you is 2 minutes to write. 2 minutes to write. Repeat. Alpha decay is a process of emission of alpha particle from the nucleus. What is alpha particle? Helium nucleus. Helium atom has two electrons surrounding this. If you remove those two electrons, what you are left with is helium nucleus. What is the charge on this? Plus 2e. From a heavy nuclei, one alpha particle is emitted to the right and the other remaining nuclei will move to the left. This process of emission of helium nucleus from radioactive nuclei is termed as alpha decay. Reaction. If the parent nuclei, this one, is written as X, number of protons Z, number of nucleons A, this is daughter nuclei Y, then the general reaction is number of protons Z, number of nucleons A. When one alpha particle, helium nucleus, is emitted, this number, yes, Z, two protons are emitted. What you are left with is Z minus 2. 4 nucleons, A minus 4, and this is daughter nuclei Y. Along with this, you will have some energy also. So, energy. As an example of the same, yes, uranium, yes, 92 to 38, check please. 92 to 38 changes to what? Thorium. Sorry, we need to write exactly below this. If one alpha particle is emitted, 238 minus 4, 234. 92 minus 2, 90. This is what? Thorium plus energy. So this is general equation, objective question. When alpha particle is emitted, number of protons decrease by 2, number of nucleons decrease by 4. Time with you is 2 minutes to write this reaction. 2 minutes to write the reaction. Momentum and energy, primarily kinetic energy. The phenomena is same as you covered in chapter number 2, 3, 4 and plus 1. If you fire gun, the bullet moves forward and the gun moves backward. Total momentum remains constant. Law of conservation of momentum. So what is the momentum before firing? 0. After this, if alpha particle moves to the right with 50 units of momentum, how much? 50 units. This other nuclei will move to the left with minus 50. Total is 0. Initial momentum 0, final momentum, this is 50I, this is minus 50I, total momentum is 0. So as per law of conservation of momentum, yes, magnitude of momentum P is equal to what? Mass of alpha, mass of y. So momentum m alpha v alpha, magnitude wise, is equal to what? My vy. Magnitude of the two will be same. Direction point of view, I repeat, if it is 50I, this is minus 50I. Direction is opposite. We are concerned with momentum magnitude. 2. Kinetic energy of a particle is equal to 1 by 2 m v square. It can be written as p square by 2m. Kinetic energy of the two is different. P square is the same for the two. Both have same momentum. Alpha particle and the daughter nuclei Y have same momentum P. That means what? Kinetic energy is inversely proportional to mass. If you want to get the ratio of the two, then kinetic energy of daughter nuclei Y, its mass of daughter nuclei Y. Kinetic energy of, yes, alpha particle, mass of alpha particle. As an example, previous question, mass of alpha particle, as an example, 4 units, say, daughter nuclei was thorium 234. In the given example, this was 234. So the ratio is 4 is to 234. Kinetic energy of this daughter nuclei is less. Why? Mass is more. Kinetic energy of alpha particle is more because its mass is less. Kinetic energy is inversely proportional to mass. So gun bullet arrangement. When you fire, bullet has more kinetic energy because its mass is less. Kinetic energy is inversely proportional to mass for this scenario where total momentum remains a constant. Time with you is 2 minutes to write. Now the question is how this alpha particle can come out of the nucleus. That is alpha decay process. Now we explain theory explanation. When this particle comes out, its energy is of the order of 5 megaelectron volt, 5 units. As per calculation, energy required inside is 25. So it appears that this particle cannot escape, but still the particle escapes. The theory is the same as that of prison break theory or escape theory. How? Number one, within a prison, 4 persons want to escape. So they will plan, they will stay together in a group. Point number one. That is, alpha particle exists in nucleus as a separated entity. Exists in nucleus as separate entity. Means as a group. 2 protons, 2 nucleons, this is one group, they stay as one group, 1. 2, alpha particle moves inside what speed? Alpha particle moves at speed. How much? 10 to the power 7 meter per second. Dia of the nucleus. Dia 10 to the power minus 14 meters. Dia is 10 to the power minus 14 meters. Time taken for this particle to move from one point to the other point, that is distance by speed. Dia 10 to the power minus 14 meters. Speed 10 to the power 7 meter per second. Time 10 to the power minus 21 second. So time taken by the particle to move from one end to the other. This particle, this group keeps on moving, trying to escape this wall, another wall, and this group tries to escape from the prison. How much time it takes? 10 to the power minus 21 second. How many attempts or frequency in 1 second? 10 to the power 21. This is how the attempts are. In 1 second, they try how many times? 10 to the power 21 times. Now there is a theory. If a probability of doing something is very low, 1 in a million, 1 in a billion, 1 in a trillion, you can increase the number of attempts. Probability into attempts is constant, finite constant. Means what? If a probability is small, if you have one chance in 10 to the power 21, how many attempts are there? 10 to the power 21. So you succeed. That means whenever you design a prison, it is with foolproof arrangement. No one can escape, but still prisoners escape. How? Because attempts are large. So this theory holds good here also. No doubt probability is very, very small, but attempts are large. So because of this, there is a finite outcome. This is point number 3. So what was the arrangement? What was the energy? 5. How much is required to escape? 25. Equivalent to, you have a wall in prison and there is a prisoner inside, can jump up to say 5 feet, but this wall is 25 feet. So theoretically, it cannot escape. But yes, they will. Prisoners will escape. How? Tunnel. That is why this theory is also termed as a tunnel theory. Time with you is 4 minutes to write. 4 minutes to write.